Hi everyone, and welcome back. In this tutorial, we'll walk through how to use Onshape to model a tapered hopper and its supporting RHS frame, as shown in this drawing. Let's get started. We'll begin by creating a sketch on the top plane. Draw a 2.4 by 1.2 meters rectangle that represents the top opening of the hopper. Once that's done, use the extrude feature and extrude the sketch 300 mm downward to form the upper vertical portion of the hopper. Next, we need a plane for the bottom outlet. Click Plane, select the top plane, and create an offset plane set to 1000 mm. On this new plane, sketch a 400 by 400 square. Align with origin like this. Now let's create the tapered hopper shape. Open the Loft tool and select the bottom face of the extruded section as the starting profile, the rectangle on the offset plane as the ending profile. This produces the full 3D hopper. To build the RHS structural frame, start with a sketch on the top plane. Draw a rectangle around the hopper. Offset outward by 37.5 mm. So the 75 by 75 RHS will sit neatly around it. To establish the RHS frame path edges, use Extrude Surface feature. And extrude the frame outline by 1600 mm. These surface edges will be used as guides for the RHS members. Now we can generate the structural members. Open the Frame tool, start by choosing 75 by 75 by 4 RHS. And selecting the 4 vertical edges. These become the vertical legs of the frame. Do the same for the 4 horizontal members. And set the corner type to none, since we'll trim the joints right after. And then click this dot to keep the top of the RHS flush with the top of the hopper. Use the Frame Trim tool to clean up the intersections. Select the members to trim. Then choose the inside face of a vertical leg as the trim reference. Repeat this for all 4 corners until the joints are properly aligned. Now we can hide the extruded surface. Next, we'll create a mid-height frame using a linear pattern. Select the 4 horizontal members. And then set the pattern direction vertically by clicking one vertical edge of a leg. Set linear distance to 800 mm and instances to 2. This gives us a neat, evenly spaced frame system. Now let's convert the solid hopper to sheet metal panels. Use Sheet Metal Model tool and Convert option and select the hopper body. Set faces to exclude to be the top and bottom faces. And set the edges to bend to be the 4 internal corner edges. Finally, define 3 mm thick and 4 mm bend radius. Onshape will now create individual sheet metal parts, complete with bend lines and flat patterns. To view them, open the sheet metal table and flat view on the right-hand side of the screen. To finish the model, let's cap the ends of the RHS posts. Use the End Cap tool and select each open face and set the thickness to 5 mm. For the bottom ends, change the cap shape to rectangle. Apply a thickness of 8 mm, an offset of 20 mm and 5 mm radii to create proper foot plates. We will now create a composite part, as all hopper panels and RHS members will be welded together in the final assembly. Select the composite part command and choose all the bodies within the model. If you enable the closed option, the individual components will be removed and replaced with a single composite body. Useful when the welded structure should behave as one part. If you prefer to retain the individual components, simply leave the closed option unchecked. This finalizes the hopper and RHS frame model. Thanks for watching.